Before we continue implementing features in this application, let's come back to that then catch error syntax. We're using then and catch error because these are methods defined on that future object based on that future class, which is built into Dart. And it's a very important class, as you can probably already tell. It helps us deal with asynchronous code. And asynchronous code is really just code that executes whilst our code doesn't wait for it to finish, as it would be the case here for our post request. You can absolutely work with features like that, but there is a more concise, a more readable syntax, which I personally prefer and which I therefore want to use from now on, and which I'll, therefore introduce now. And that's a syntax called async await. You also have that in JavaScript, for example, if you're familiar with that. And you can simply handle features with that in a more elegant way. Technically, behind the scenes, they work in exactly the same way as you learned it. You use that syntax by using the async keyword, by adding the async keyword after your parameter list before your curly brace on a function or method. So you need to do that on a method or a function, and then you add async here between arguments and curly brace. By doing that, one important thing happens. All the code you have in there automatically gets wrapped into a future. So when using async here, the function or the method on which you use it always returns a future, and that future might then not yield anything in the end, but it always returns a future, because this now is all wrapped into a future. Therefore here, we don't have to return our future anymore, because we automatically have this all wrapped into a future, and that future will also be returned automatically. So that's some magic happening behind the scenes. Now, the idea with async, with the async keyword, is that we can now get rid of then and catch error. Instead, we can now use another keyword here, the await keyword, and that tells Dart that we want to wait for this operation to finish before we move on to the next line in our Dart code. Now, important, with that we don't change the rules of how Dart works. Behind the scenes, it still transforms this to this future syntax with a then method. So it still simply wraps the code which comes in the next line into a then block. It doesn't pause code at execution, but to us it looks like it does, and it simply turns this into a more readable code, which is more similar to the code we wrote thus far, where we also had the situation that line after line executed. So here with await, we're telling Dart that it should wait, in quotation marks, for this to finish, or in other words, that it should wrap all the code that comes after this into the then block that it invisibly adds. It means, however, that we can get rid of then here, and also can get rid of catch error, like this here. So let's get rid of all of that. Let's comment that out for the moment here. And with that, of course, the question is, where do we now get our response from? Well, we can now actually use this here as if this would be a synchronous method, so a method which finishes immediately, which doesn't continue in the future and eventually finishes. And therefore, we can simply store the result in a variable, or like here, in a constant. So we can now assign the result of this operation to a constant with the help of the await keyword, which is available because we use async here. So with that, we're storing the response in the response constant. And now the code in the next line, so here, will only execute once this is done, because the code in the next line is invisibly wrapped in that then block. So in here we have the response constant available, of course, due to the syntax here, and now all that code runs just fine as before. Now with error handling, we of course have no catch error method anymore now. But you can use an alternative approach. You can use an approach which is also built into Dart, which we haven't used thus far, but which you can use on any synchronous code, so normally on everything but futures. And since this now is written like synchronous code, you could use it here as well. You can use try catch. With try catch, you add a try block with the try keyword and curly braces around the code which might fail. So I added try and then a curly brace, and then before my closing curly brace here, so inside of the curly braces, I have all the code which might eventually fail. And there you should not put your code, which could fail because you were lazy to properly test it, but code where you can't rule out that it fails at runtime. For example, code that depends on user input, or that depends on an internet connection which might not be there. Hence, HTTP request is a great candidate for trying it, because you can't guarantee that it will succeed, because there are too many factors beyond your control. Now, try doesn't work like that. Instead, you need to add something else. You need to add a catch clause here with the catch keyword, and then between parentheses, an error object which you catch. And then you have another pair of curly braces, and between that you put the code which should run when this throws an error. So here, I can now actually take that code and move that into my catch block here, and use that error which is passed as an argument, so to say, into this catch block. So this will now run if the code between try causes an error. Now this code here, of course, also should only run if we have no error, so I'll also move that into the try block, because all this code here depends on this succeeding, so I'll move it into the same try block here. And with that, we have a setup where we can use this try catch feature, which again is available in Dart in general, and you can use it anywhere in your Dart code, not just when working with async await or when working with HTTP. You can use it on any code where you have reason to think that it might fail and you can't rule that out during development. And then you can write code that should run when this fails and write code that should run when it succeeds, or which you want to test whether it succeeds. And that's similar to then and catch error, of course. So with that, we have this setup here in add product, and I'm using async await here. Now, just because I'm using it here doesn't mean you also have to use it in edit product, for example. There, we're also using that add product future. And remember, due to us using async here, this automatically returns a future here. So in edit product screen, we now get back that future, and we can still work with catch error and then there if we want to. But we can also use with async await there. So here I can also add the async keyword after my parameter list before the curly brace. This therefore here also yields a future which eventually yields nothing, which isn't a problem here for the rest of our code. That's fine. And then here we have all that code. This here is still synchronous code, all good. But here we have async code because add product returns a future. And here we can therefore also, of course, add await instead of using then. Now we could store the result here in some variable or some constant, but actually add product doesn't return a result. It returns a future which yields nothing, and that nothing certainly is not something we would want to store. So I'm just awaiting here. But of course, now I'm not using catch error anymore, but I'll again wrap this into try catch here. So I'll take that code, move that into try, like that, and then catch my error here. Get rid of that catch error clause there. And instead now take that code, that dialog code here, cut that, and move that into catch. So with that, I'm catching my error here now, and I'm then showing that dialog if an error should occur. And we can also get rid of that closing parentheses here. Now this code here, setting the state and popping, should always run, no matter if we succeeded or if we then ended up in the error block. And for that, on try catch, you can also add a finally block, another keyword, only works in conjunction with try and catch. And that defines some code which should always run, no matter if you succeeded or if you failed. So here, we can now move our code here, which should always run, into finally, but important, show dialog returns a future, which will resolve as soon as the user press this button, or in other words, it will resolve as soon as this dialog is popped off the screen, which happens when the user presses this button. And therefore here I actually also want to await for this result before we continue to finally. So with that, we're using async await, and the app should now work just as before. And for that, I'll actually reintroduce that error here so that we can see whether that's the case. So let me refresh the app with that error reintroduced, and let's see if it still fails. If we go to manage products here, and we then try to add a new product, this should fail, of course, because I still added that error, and hopefully it should still be handled. So if we now press the save button here, we get the dialog, we don't navigate away until I click OK, but then we do. So we have the same behavior as before, but in my opinion, async await is more readable. You just have to be aware that behind the scenes, we're still working with a future, and this still gets wrapped into then and so on.